Hey everyone, welcome back to our YouTube channel Concepts Decoded. Today we will talk about kernel SVM. So, talking about today's topic, we use a set of techniques known as kernel methods. These functions are used to compare the similarity of two data points in a dimensional space. So, what does SVM have to do with kernel methods? SVM uses kernel methods to transform the input data, which makes it simple to distinguish between classes. Now, talking about the types of kernels, the most commonly used kernel function in SVMs is the Gaussian or radial basis function. But there are many more types, such as polynomial kernel function, sigmoid kernel function, hyperbolic tangent kernel function, and etc. So, let's understand it with a simple example. Let's imagine you have a bunch of colorful balloons that are red and blue balloons, okay? And you want to separate them in two groups. What does regular SVM do in this situation? Regular SVM is like drawing a straight line to separate. But what if your balloons are arranged in a circle? So kernel SVM in this case allows us to look at balloons from above. Now instead of drawing straight line, you can draw an imaginary circle around red balloons to separate them from the blue ones. So, in simple terms, kernel SVM helps see things that are not in straight line and help us see patterns that are not obvious at first glance. This was the brief about kernel SVM, so let's see how to write the code for it. So first step is always importing libraries. Now we will upload our dataset. Copy the path. Now we split our dataset. Printing our data. Now we will do the feature scaling from. Now we will train our SVM model on the training set from which we will do this step SVM import. Now we will predict a new result. And we will predict now the test set results. Y paired. Now we will make a confusion matrix. So we have the accuracy 9.30.93 and we have the confusion matrix. Now we will do a visualization for, first we will do for training set and then we will do for test set. We have visualized the result for the training set. We will do the same for the test set. So Okay, so we have the visualization graph of the training test set also.